So, hello everyone, and good evening, and welcome to all of you uh, for this episode number 10 of our online series, that is the project discussion series. So, I hope my voice is audible and you can see me online. Okay, good. So, sorry for joining a little late today. We had some work to be done, which made us late. So I hope you are all in good spirits. This this year of 2022 is soon going to end, and let us end this on a technical high. So, what is going to be the agenda for today? Let us quickly see before we proceed. So then let us start with our first segment, that is going to be the problems, where we take up some problems which are commonly faced by practicing structural engineers and try to discuss their probable solutions. So the problem that we are going to take, and I'll share my screen, and let me just open a small presentation that we have made over here. So I hope the presentation is visible. Yes, I hope the presentation is visible properly. So what are we going to discuss? As I said, we every episode we take up some problem, and those problems are ones which are commonly faced by practicing structural engineer, and we discuss their solution. So this episode we will take up discussion on application of wind loads using ETAPs. So we will be applying and we will be discussing wind load application using three different techniques. So before I move ahead or before I go ahead, how many of you have applied wind loads in ETAPs? How many of you have applied wind load in ETAPs? So I think if I ask you what is the way in which you apply the wind loads, do you calculate the UDL manually and then apply those UDLs or distributed load on the members? Is that the way you apply wind loads, or how do you apply? If I'm audible, if someone can just type in. So how is the wind load applied by you? Let us see. So the commonly used techniques are, and before I go to techniques, I'll just go to the building that we are going to take for our wind load application. So here you will see a sample building that we are going to take over here. Parth is saying that he applies using the CF factor. No, no, I didn't mean the wind load calculation. What I was trying to ask you that how do you apply it in the ETAP software? Okay. So before I go ahead, we will be taking this. We will be taking this sample building for our wind load application. Okay. So it's a simple rectangular building that we have taken, and it is 24 meters by 12 meters. You can see the plan view. You can also see the elevation. So it's a G plus 3 structure. Each story height is 3 meters. So the overall height would be 12 meters. Okay. The basic wind data that we are going to consider for this discussion would be 50 meter per second wind speed, K1 factor of 1, terrain category 1, K2 1.05 till 10 meters because of terrain category 1, and 1.09 at 15 meters because the K2 value changes with the altitude. But in this discussion, we will take 1.05 as the K2 for the sake of simplicity. K3 is 1, K4 is 1. The design wind speed therefore will come out to be 52.5 if I multiply K1, K2, K3, K4 into the basic wind speed. Okay. KD, directionality factor, area averaging factor, and combination factor, we have taken them equal to 1. A reason for taking them 1 is because the ETABS version 18 does not allow you to input the values of KD, KA, KC. So that's the reason we have taken them as 1. So this is the wind pressure that we get, 1.653 kilonewtons per square meter. So this becomes my PZ. And let us consider that this is a clad building. So the external wind coefficient is zero point 0.8 and internal coefficient is zero point 0.5. So this is what we are going to, this is the coefficient that we will use for all our discussions. Okay. Okay. Moving ahead. So now we will discuss the various methods of wind load application, and we will apply this calculated wind load PZ on our building. So method 1, we will apply the wind loads as per uniformly distributed loads, and we will apply them on columns. Okay, what Mr. Tafazzul is saying, manually calculating and applying it linearly on the members. So this will be our first method through which we will be applying wind loads. Remember what we are doing in this discussion, we are going to apply wind loads using different methods, and then we will compare the outputs, and we will try to figure out which method is more suitable or which method is more advantageous. The second method we will discuss would be applying loads on the null area. So how many of you have applied loads through this method? Applying with loads on the null area? Yes, anyone in the audience? No. Okay. The third method we will discuss would be applying loads using the diaphragm assignment. Okay, so these are the three methods. ETABS offers you these three distinct methods to apply wind loads, and that's what we are going to compare, and we will see which method suits well. So let us start with our method 1. As I told you, the external CPE I will take it as zero point 0.8, CPI I will take it as 0.5. Don't worry, why did I get, how did I get 0.5? Why did I get 0.8? Don't worry about that right now. Of course, all of us can calculate it from IS 875 part 3. So Anshul is in the audience. He has tried all the three methods of applying wind loads that we are going to discuss. Very good. That's good. So the this is, remember, method 1. Just remember the method and what we are doing in this method, because I will be referring to only the methods henceforth. So method 1 is applying UDL on columns. So we have calculated the UDL on internal column. Spacing is 6 meter. So you can see the UDL. We have similarly calculated the UDL on external columns, and then we have applied it like this. Okay, we have applied it like this. If you can see on the screen, wind load applied as UDL. Here you will notice that I have only applied the wind load on the windward face. Right now I have not applied it on the leeward face or on the side faces, only on the leeward face. Only on the windward face for this discussion. So the wind loads have been applied. You will notice one thing, that I have not applied the wind loads on the bottom half of the lowermost column. If someone has noticed it, wind loads have not been applied on the bottom half of the lowermost column. Okay, there is a reason why we have not applied wind load over there. Anyway, so this is the method 1, the regular way in which we apply wind loads. I'm sure most of us apply wind loads using this method. Yes or no? Yes, I think most of us do it this way. Okay, then we go to the method number 2. So in method number 2, what we are going to do, if you recall, we are going to apply wind loads on the null area. So that's what we are now going to do. For this, we need to first create a wind load definition in ETABS. Okay. So here, if you can see the screen, we have created a wind load definition. and we have selected the IS 875 part 3. And then in the lower window, lower screen, I think you can see over here, is my, is this what I'm writing visible? Yeah. So here you can see that we have taken this from exposure from shell objects, and then here we are manually assigning these values. So we have assigned wind speed, terrain category, importance factor, uh, K1, K3, K2. It will automatically calculate from the height. And what about Ka, Kd, Kc? What about the Ka, Kd, Kc? So Ka, Kd, Kc unfortunately cannot be, uh, is not available in ETABS in this definition. Okay, so the directionality factor, the area averaging factor, and the combination factors are not. You don't have the option to input those. Okay, so this is what we have done, defining wind loads. After defining wind loads, then we have created these null areas. So if you can see, these null areas we have created on the elevation. Again, you will notice on the bottom half, I have not created any null area. Then after creating these null areas, we will select all these null areas. You remember we already have a wind load definition in place. So now I will select all these null areas, and what shall we do? Then we will go to assign. I will go to shell loads, and we will go to this wind pressure coefficient option, and then we will, under the, let's say, load case wind, I will give these coefficients. So here you will see I have given zero point 0.8 plus zero point 0.5. Why so? Because I am going to add CP plus, sorry, I am going to take CPE plus CPI to get the worst result. So here I will have to manually input these values. Mr. Rahul is asking which version. It is the 18 version, 18 point something. It is 18 point something. Okay. So I have put the CP, CPI, and then we assign. So you will see automatically this 1.3 coefficient has been assigned, and ETABS has manually, I mean, ETABS has on its own calculated this wind load. So this is actually 39 point some kilonewton, which is being applied on this area. You understand? This particular load is being applied on the exposure area that we have, on which we have created our null area, and you can easily cross check it. You have the wind pressure as 1.653 kilonewton per square meter. You multiply it by this distance. This is 6 meters, and this is 3 meters. You do the multiplication, you will get this value. You might get a slightly different value because of the changing K2. So I think ETABS will take a K2 of around 1.09, because it will interpolate after 10 meters, whereas we have done the calculations taking the same K2 as we had at 10 meters. Anyway, but your values will be matching. So this is how the loads have been applied in the method 2. Okay. So two methods. Now we go to the third method, applying loads using the diaphragm assignment. So I think someone had mentioned that they have used this method for applying wind loads. So in the diaphragm assignment, first you will have to assign diaphragms at every floor level. So this has been done. Then you again have to go to the definition. Once again, same. I have defined this, and you will see we have taken this option this time, exposure from extents of diaphragm. Again, these coefficients same, and it will do a CPE plus CPI. Again, the same basic wind speeds, terrain category, importance factor, and all those things. Then what we do next? So we have chosen the exposure from extents of diaphragm. So automatically, if you see, uh, I think there is a extra, uh, I mean, in the PPT, there's an extra thing that had. Just give me a minute. Just give me a minute. I think there is some. Uh, what should I say? Yeah, there was one image which was there unnecessarily. So I'll just remove it. And once again, I'll share. These things happen when we don't get enough time to do the editing. So today, due to some reason, I could not get sufficient time to do the editing. Anyway, so can you see it now? Yes, I think we can all see. There was some other image that had stuck, so I had to remove it. So now what we have done, I'll go back. Here we have chosen the option to take exposure from extents of diaphragms. And now if you see, what do you find over here? Yeah. So automatically, this is, let's say, at 0 degree. Wind is at 0 degree right now. You can see 0 degree angle. Here the input is 0. So automatically it calculates the width. Width means this distance perpendicular to the wind direction. So here it has automatically calculated it equal to 24, and this distance will be the depth. Again, automatically it has worked it out to be 12. So this calculation is done automatically by ETABS on its own, as per the diaphragm assignment. Okay, so that has been done. Quite interesting. We will see it later. And this is how ETABS will apply the wind loads at the diaphragm center, and then it will distribute the loads to the frames as per their in relation to their stiffnesses. So this is what we have done. All the three models are analyzed now, and now we will compare the results. So very interesting. Let us compare the results first. So here you see just a comparison of base reaction. What this helps me to understand is that what is the total wind force being applied. So if you see, this is the base shear in a way. So in effect, it would be the total lateral force being applied. So in method 1, 541 kilonewtons. This we had manually applied as UDLs. In method 2, 544 kilonewtons. This we had applied the loads on null area. And in method 3, where we had assigned loads on diaphragm, same 543 kilonewtons. So if you see, the total lateral loads, total wind loads applied in the model are almost similar in all the three methods. Okay, also you will see the same overturning moments, almost the same overturning moments for all the three methods. So this also tells us that not only the total wind force being applied is similar, but also the distribution is more or less happening similar. Okay, do you get it? So these two things tell us that not only the total wind force applied is same or similar, even the distribution of the wind forces along the height are almost same. So it's quite encouraging. Both the values match for the three methods. Now we are taking the M33 moments for the internal frame. Internal frames means which were on my grid B, which had a tributary width of 6 meters. So this is as per method 1, as per method 2, as per method 3. You know which method stands for what, and you will see almost similar moment values you are getting, right? In the beams also, and in the columns also. Do you get it? Almost similar. Here there is a variation, and here there is a variation, but otherwise, if you see, these are quite uh, matching to each other. Okay. Then, if I compare the movements on external frame, even these are having a good match. You can see all the values. Then, if I compare the axial forces, these are the axial forces on internal frame. This yellow line indicates that there is a tension, and this indicates there is a compression. So all of you know lateral loads. To resist lateral loads, there will be a axial tension compression couple created. So this is also matching quite well. Axial forces, external frames are also matching quite well. So more or less, all the three methods are giving you similar results. So the question now is that which method should we use, or which method you think is a better fit? Yes, anyone? Which method do you think is a better fit? Now that we have almost seen that all the three methods are giving us, uh, almost comparable values, which method would be a good method for mid-load application? Yes, anyone? Which method to use? So what I want to say over here is that this diaphragm method of wind load application has certain advantages over the other methods. And what are those advantages? So number one, it is easy to apply. You saw in the diaphragm assignment, we don't have to calculate manually anything. You don't have to first calculate then assign on the members. It is time consuming. Okay. So it's an easy application. Mike is asking this question, which method is better? Is it for buildings or structure? No, I am talking about buildings right now, general buildings. I am talking about general buildings. Of course, in complicated structure, you cannot expect the software to do auto load application. You will have to manually calculate and apply. That's quite sure. But here we are trying to ask is in building type structures. So diaphragm method, what are the advantages it has? Number one, it is easy to apply. Number two, loads can be applied at other wind angles also. So not only at 0 degree, you can also assign wind loads at any random degree. We'll see how. Third is ETABS is able to identify the wind effect for different angles, and then it sort of finds out the enveloping values on its own. Okay. Fourth is that the load combinations. Let's say you have different wind directions if you make them manually. So all of you know if you have, let's say, a wind in X and if you have a wind in Y, then you have to make whole lot of combinations over here, correct? And all those combinations need to be made manually. So here, if we use the diaphragm assignment method, then we do not need to make all these combinations on our own. ETABS will automatically do it for us. So these are the advantages it offers. So let me just uh, detail more on the advantages. So now if you see here, I have applied the wind loads in different angles. How I have done that? In the wind exposure width data form, I have just put a angle, then I have put a semicolon, then we have put the next degree angle, semicolon. So you keep on putting semicolons, and you can put as many angles as you want. Okay. So in this way, you can apply wind loads in different angles, and automatically you see 13 different load steps have been created internally. So for each angle from 0 till 360 degree, it has automatically created for different wind angles a separate page. Okay. And then it also calculates the exposure widths on its own. So you see for a 30-degree angle, this was actually 30-degree. You can see for a 30-degree angle, it will calculate the width and it will automatically calculate the depth. So these calculations are done on the basis of the diaphragm extent. So here I've just put a small figure how these widths are calculated. So suppose this was my diaphragm extent, red box. So the exposure width is calculated by this perpendicular distance where it meets the extreme point over here. So geometrically, this distance becomes your width. You can do a simple geometry in AutoCAD and you will understand. Similarly, this point and its perpendicular distance, this becomes the depth. Again, it can be easily verified in the by using a simple geometry check in AutoCAD you can do this quick exercise, and you can understand and you can verify these exposure widths that are being calculated. So what I wanted to say that for different angles, it will automatically calculate all this data for you. Okay, you don't have to worry. Everything is done by ETABS on its own as per the wind angle, and then once you run your analysis, you get the output for different wind angles shown as per the step number. So here now you will get from step number 1 to 13. So for each wind angle, uh, 0, 30, 60, 90, whatever, you will get the outputs in form of these steps. And then the good part is that you can combine them in a particular load combination. So for example, here I have created 1.5 DL plus 1.5 wind, and internally all the combinations will happen for all the possible winds. That means it will automatically create all these, so to say, 13 combinations internally. Are you following? Okay, 60 and so on. So automatically all these combinations will be created, and it will give you, either you can see the stepwise values. That means if you want to check for this, you can check it. If you want to check it for this, you can check it. Or you can get the enveloping values in terms of max and min. So this is quite easy. You don't need to make any other combination. It will just make your life quite simple. So to conclude, there can be three possible methods to apply wind loads, but the method which is more easy, which is easier, and which offers you great working ability, in my view, would be the diaphragm method. Okay, is it clear? So diaphragm method, in my opinion, is a good method to apply wind loads, especially for your uh, building like structures. Okay, good. So this is what I wanted to tell you. Rahul is saying ETAS 20 also does not have the input for KA, KD, KC. Yeah, ETABS 18 also does not have it. So I think that is a missing point in the ETABS definition right now. So if you have the values of KA, KD, KC that you want to apply, then perhaps you will have to apply it as per the, you will have to do some adjustment in your pressure calculation somewhere, or you will have to do adjustments in your, uh, what should I say, in your coefficient somewhere. Okay. So this is what I wanted to tell you regarding the method of load application using ETABS. So I hope this is understood to everyone. Mr. Sunil is saying diaphragm method can be applied for industrial structure, that is for ridge frame structures. I think he's asking for a truss type of or a pitched roof structure having a pitched roof. Yeah, for pitched roof, I think this method will not work quite well. As I told you, this method of diaphragm assignment will work when you have a, uh, what should I say, when you have a building like regular structure. Yes, Mr. Sandeep is saying that we can, if we have problems with any of the coefficient, we can apply it through the user load option. Right. We have the option of assigning it through user load, and we can assign it to the diaphragms directly. Right. Correct. So I hope this discussion was helpful, and you understood what are the various possible methods to apply wind loads, and which method will be um, of more advantage to you. Okay. Right. Before I move to next segment, Ashish is asking, in axial force image in column, why tension then compression then tension then compression? It should be tension tension then compression compression. No, actually, for the internal columns you get this type of a behavior. The tension compression switches for the internal columns. The value was numerically quite low, but yes, you get this type of a behavior. Mayank is saying for diaphragm forces, is it necessary to model floors or it will automatically calculate from joint diaphragm? From diaphragm forces, is it necessary to model floors? I mean, yeah, you have to model floors, right? Oh, acha, he is asking, do you need to model the shell elements or will it automatically calculate from joints? Yes, this is one thing that I did not check, but I think it should do it if you don't model the shells and if you only work using joint diaphragm assignment. I think it should work. Kashyap is saying if other than regular structure, circular, other shape, what method to apply? Yes. So my slideshow was still remaining. Actually, I ended it slightly prematurely. So let me go back. So we in this type of structure, if you see what Kashyap is asking, this was the last slide of my presentation. So in this type of project that we were doing in one of our courses, we had used which method we might have used? Yes, which method we might have used for this type of a structure? So we used the method of wind load assignment using diaphragms. Okay, so because you see such a complicated shape, we use the diaphragm method in this case for load assignments. Wind load assignment I'm talking about. And what we did that we created different diaphragms like this. We made different diaphragm assignments, something like this, and then we applied wind loads on this structure using the diaphragm assignment option. So it's quite convenient actually. It is automatically ETABS is able to assign all the angles, different angles. It will automatically assign. It's quite convenient. It's quite convenient to assign it that way. Yeah, good. So this diaphragm method will help you to assign wind loads on irregular plan shapes also. So I hope this was interesting. Yes. Mr. Mayank is saying, oh, his question is continuing, I think. Because what if there is any skip floor in structure? What is skip floor? I'm not quite sure what skip floor is. Anyway, so I hope this discussion was interesting. So we understand what are the different methods of wind load application in ETABS and which method might be more suitable and convenient. Good. So now we move to our second segment where we generally take up some interesting discussions related to related to situations that you face in your real life projects. So this time uh, we don't have any project per se, but what we are going to discuss is going to be an innovative use of cold roll sections. Okay, so I think most of you know what are cold roll sections. So we will see an innovative use for it. Yes, Mr. Venkatesh is asking why are we creating different diaphragms for single floor? Yeah, because initially we had, we were going to provide in that project that you saw on the screen, we were going to provide the seismic gaps because it was not a very good seismically, uh, because the structural shape was not very good with respect to the seismic actions. Therefore, we were going to provide seismic gaps in that structure, and therefore because we were going to provide seismic gaps, we assigned different diaphragms because anyway we were going to isolate those parts from one another. Okay, that's the reason. Okay, so moving ahead, we are in our second segment. We are going to discuss an innovative use of cold rolled steel sections. I think all of us understand what is the meaning of cold rolled sections. Yes? Yes, I hope we understand. So, they have large usage in different structures and structural system. CRS, what is meaning of cold rolled sections, are being extensively used. An innovative use that we are going to discuss, that cold rolled sections are being extensively used these days, and uh, more so in India these days for making agricultural storage silos. Okay, so I don't know whether anyone has seen agricultural storage silo, steel silos, white sheet metal silos. Has anyone seen them? White sheet storage silos? No. Okay, so we'll discuss. Okay, so why we are discussing this? Because in India, the food grain storage loss is a big loss that our country suffers. Almost 6 to 7% of annual loss of our cereals, I mean grains, is because of the produce, yearly produce exceeds the storage capacity that we have. So actually, food getting wasted because of rotting is a very very big problem in our country. Okay, so we don't have proper storage methods. We don't have uh, we don't have proper capacities to stock our produce. So there is nearly 7% annual loss in every year that we face. Okay, so we are a food surplus country, but the storage system still needs improvement. So if anyone has visited any warehouses or godowns, they might have seen that the storage happens in bags, gunny bags, or the storage is just done in the open, and this leads to substantial wastage and rotting of grains. So what is a better way? A better way is to store grains in the silos, agricultural storage silos. So this is how grains are stored or stacked. Open grain storage you see in gunny bags, and then you just cover with a uh, PVC sheet, which acts as water, which resists water as much as it can. Or the storage happens this way. Okay, open grain storage. So you just put a stack of any grain in the warehouse. So these conventional methods lead to a lot of wastage and lot of rotting of your cereals. So this is a better way to store grains. Has any one of you in the audience seen such a project anywhere where they live, where near they live? Anyone has seen? Okay, so this is a storage method where the cereals are stored in specially made steel silos. So all these white things that you see are steel silos. Okay, and of what material are they made of? Of what material are they made of? So they are made of cold rolled steel sections. So that is why we are having this discussion, that this entire silo complex, this is called a battery of silo. This is entirely made up of cold rolled sections. So typically there will be a deck sheet that will act as the silo wall. Then you will have some vertical members, again cold rolled. Then you will have the top dome, again made out of cold rolled rafters, purlins, sheeting, etc. So this entire system that you see is made out of cold rolled sections. Okay, and then you store your grains. So instead of storing grains in gunny bags or open storage, you actually put them in the silos. Do you understand? So the grain will come, it will be stored in these silos. There are these conveyors at the top that you see. These will take the grain from bottom. So grains will come in the trucks. If I could just explain you the process quickly. So grains will be brought by the farmer, let's say, in trucks. Then they will unload it. The grain goes to this elevator. From elevator, it goes to this conveyor, and individually it will drop down in the silo. Do you get it? So this is the process of feeding the silo. When you want to take out the grain from the silo, all these silos are connected at the bottom through an underground tunnel, which you cannot see right now. So the grain will be discharged from here. You are filling it from the top, emptying it from the bottom. So grain will discharge. Then the grain will flow through this tunnel with the help of a conveyor assembly. Then it will go to this small silo, and then it will be fed in these day use silos. And from here, it will be taken in trucks or it will be filled in gunny bags. Okay. So this is an innovative use of structural cold rolled steel sections in these types of project. This image has been taken from the website of Adani Agri Logistics. They are one of the biggest players in our country right now. So a different view, again image taken from the Adani Agri Logistics website, and this is again another image where they are actually comparing the conventional storage in gunny bags or open storage versus the storage in silos. So here they are saying that it needs one third as much as land, high tech preservation techniques, and you can ensure good quality. There are negligible losses, improved shelf life. You can store grains for a very, very long time. You can actually do a lot of real time monitoring. There are a lot of sensors that they put, and you can check the temperature, humidity. You can check them against any infestation, etc. And the transport is also quite easy. So as I told you, you take the discharge from bottom, and you can either directly put them in the rail wagons if you have to do a bulk discharge, or you can fill it up in gunny bags, or you can fill them in trucks. So there are a lot of options that you have to store sorry there are a lot of options that you have to discharge them. Again, similar silos, a different project. uh, Not only silos, but if you see, these are the uh, warehouse. This is called a day loading no, this is called a bulk loading silo. This is also made out of cold rolled sections. In fact, this entire elevator tower that you see, or this conveyor assembly that you see, everything is made out of cold rolled sections. You get it? So we understand that cold rolled sections are only used for making purlins, isn't it? Or cold rolled sections are used for making deck sheets at the most. But here you see an entire structural industry being made out of cold rolled steel sections. So actually, cold rolled steel sections have a very big advantage when it comes to their usage. This is again, you will see a battery of silos. I just mentioned some big silo facility owners in India and some big manufacturing companies. Okay, some big manufacturing companies. So Shirke is Pune based. This Ben and Jaws is based in Delhi. Fowler Westroop has an office in Bangalore, I think. And these last two companies are Turkish in origin. So these are some big silo manufacturers in India. When I say silo manufacturer, I'm talking about this entire assembly, entire uh, grain storage system that they manufacture and supply. Okay, very interesting. So we come to our point of interest, and we try to understand how a typical silo would look like. So this what you see is a corrugated sheeting. Okay, so this is a corrugated sheeting. That means there will be crest and troughs, and you take a plate and you roll it into this shape. Okay, and the corrugations will be placed like this. So all these sheets are horizontally spanning. Do you understand? All these sheets, corrugated sheets, we place it in such a way that they are horizontally spanning. Then there are vertical members. So if you see, these are the vertical members. Can you see them? So these vertical members are also made out of cold rolled sections, and you will have a typical standardized shape, something like this. Okay. So in fact, the connection happens this way, that your vertical member is like this, and your sheeting is attached in this fashion. Your corrugated sheet is like this, and vertical members are placed like this. So the corrugated sheet has a horizontal spanning. Then you have a top dome, again made out of rafters and purlins, cold load sections, and then at the top you have a compression ring to support this top dome. Okay, so this is the general structural system that you see. Then what else do we have? Yeah, so I have just mentioned the structural systems, corrugated sheets, vertical cold roll members, horizontal pipes. There are actually some horizontal pipes over here at certain intervals just to keep that entire sheet assembly in place. Okay, so there are some, they call it as the wind pipes. So there are some small horizontal pipes that they provide, which are made out of circular pipes. Then you have a top dome, as I told you, top dome rafters. These are made out of generally cold rolled, but you can use hot rolled sections also. Then you have a top compression ring, bracings. Again, you can have them made out of cold rolled or hot rolled sections. And at the substructure, you will have a RCC wall. I didn't show it because it was RCC element. So here you will have a ring wall, RCC, and then you will have your RCC substructure depending on the geotechnical conditions. Okay, so this is how the entire structural system looks like. What are the loads to be considered? Very quickly, you have to take the dead load, you have to take the grain load. So your grain will have a horizontal effect, and it will have effect due to skin friction on the silo sheet wall. So these calculations are done to be done as per IS 9178. Then you will consider the live load on roof. I have mentioned the code. Wind loads as per our standard 875 part 3. For seismic load, your 1893 does not have a very good criteria. So there's a European code actually, DIN 1055 part 6. You can refer to the particularly seismic load calculations. You can refer to this European code because IS 1893 does not have sufficient provisions. Load path, just for our understanding. So when you have the grain load, first it will be, of course, it will act on the corrugated sheeting. From the sheeting, it will be transferred to vertical member, then to RCC wall, then to the RCC substructure. Whatever load you have on the roof, you remember you had this type of a roof. So whatever load you have on the roof, of course, easy. That will be transferred on the roof sheet, from there to purlins, from there to rafter, from rafter to vertical members and substructure. Same load path for the wind also. So whatever wind load acts on your sheeting, that will have this load path, corrugated sheet to vertical member to RCC wall to RCC substructure, and whatever load wind load acts on your roof portion, that will of course have the similar load path that we had for live load on roof. And for seismic, because most of the load will be due to the grain, so that will act on the corrugated sheet first, then to this, then to this, then to this. So simple load paths you have for your seismic loads. Now, if I could just show you some of the elements in their drawings. So here I have actually removed the dimensions because we did not want to give out any data on the internet. So I have removed all the dimensions from here. So this is a typical corrugated sheet. In this, you cannot see the corrugations right now, but the corrugations will be like this. Okay, it will be corrugated in this direction. So this is the horizontal one width of the sheet that you get. It is typically around 1200 wide. Okay, and this height also depends on the what you are going to as per your silo geometries. So you see all are these bolt holes. So Mr. Venkatesh was asking how the sheets are connected to each other. So they are not welded, they will be bolted to each other. Okay. And this portion that you see, these will be for the vertical members. So your vertical member will come over here, and they have provided so many bolt holes. You don't have to put bolts everywhere. You will put bolts wherever required. Okay. So this is how your corrugated sheet looks like. This is a typical section of your vertical member. So here you can see the geometry of a vertical member. Your sheet will be attached to the backside like this. Are you able to imagine it? Yes, I hope all of you are able to imagine. So this is how your sheet is uh, put. You will see slotted holes just so that you have enough margin while attaching. Then these are horizontal pipes. I had told you that you may have to provide horizontal pipes just to provide some lateral stability against wind. So it is this. And this is your roof assembly. So you can see rafters. These are the main rafters. This will be your compression ring, and these will be your purlins. And on top of purlins, you will have your sheet. So this is what a typical roof assembly looks like. And all in all, if you want to create a model in 3 Stat Pro or any software like that, you can see very easily this model has been created with all the sheetings, vertical members, everything. Okay. This is a model without the sheets. Sheets have been removed from the view. And what else do we have? This is the top view. So very easy. Actually, very easy system. How the assembly is done on site. So how it is done, I'll just explain that first you have to place this roof assembly. You see, this roof assembly is placed, and then you put jacks all around the periphery, and then you start lifting this roof assembly. You start lifting this roof assembly with the help of jacks, and then you start stacking these sheets one below the other. Are you getting it? So first you have to make this roof assembly, then you lift it, and then from below you paste this first. Let's say you put this first layer of sheeting, then you lift it again, you put the next layer of sheeting, and so on. So in this way, you start from here, and then you go on lifting. So here still the roof assembly is being placed, and they have put the first ring. So this ring effectively will go where? This ring, once the installation is complete, it will reach the top actually. I hope you understand. So this ring will reach at the top, and then sheet rings from below will be placed. Okay. Yes. So you can see the lifting is ongoing, and they are adding sheets from below. So this is what I had to tell you, and we hope that you have understood that how we can use cold rolled sections in the agri storage silo projects as shown. So actually, the cold rolled sections are getting a very big market for these storage systems, and there is a lot of scope for engineers who can actually do the design and who can understand and work with these systems. So I thought I'll just tell you this because it is an interesting uh, avenue for the structural engineers to work in. Right. Very interesting. Mr. Kashyap is asking stat connection to RCCS pinned. Yeah, because you just put simple bolts, you don't have a big anchor bolt and all those things. You try to create a simple pin assembly. And anyway, because it is so closely placed, all those members, anyway, you don't get a very large moment magnitude. Okay, right. Mr. Venkatesh is asking why have they preferred cold rolled over hot rolled? Of course, because of weight. Because typically all these sheet metals that I saw that I showed it to you, they are typically around 4 or 5 mm at the most. Okay, so because you don't want to have very heavy weights, of course you want to make your structure light, so therefore you prefer cold rolled sections over hot rolled. Is it insulated too? No, the grain storage silos are not insulated generally. There is no requirement to insulate it actually. So they are not insulated. Okay. So I hope this discussion was interesting and I was able to explain the use of cold rolled sections for a innovative structural system, that is the agri storage silo. And I must say over here that in not uh, distant, not in not a very distant future, I think India will have the largest number of these types of silos in the future. Okay, if I could just tell you, if I could just go back to this presentation, and if I could just ask, so a typical silo like this that you see, one silo, it can hold around 12,500 tons of grain. You see one silo over here, so it can hold around 12,500 tons of grain. It will be typically, this will be around 30-32 meter dia, and it will have a height of around 22 meters at eaves. Okay, so 12,500, you can count the number of silos, and you can understand how much storage has been created over here. Okay, right. Mr. Venkatesh is asking what is the R value. So R values are not quite properly given in the Indian standard, but I have seen many designers taking an R value of 1.5. That is for the steel part. Of course, grain has no R. Okay, so grain that is stored, it will also push the silo shell wall, so that will be a different issue altogether. Mr. Ajay ji is asking seismic design, if you can tell. So in seismic design calculations, mainly what is done, that all the materials over here will have different damping factors actually. Okay, so your grain has a very high damping factor. It will have a very high damping ratio. So you will take that, because of very high damping ratio, it will have a low multiplying factor. So in typical calculations, they take a 10% damping for the grain stored inside. Okay, they will take a 2% damping for the steel and 5% for RCC. Okay, so grain, I mean, although the grain has a very high volume and weight, but because the grain has very high damping, the overall multiplying values of grain come down. uh, but Indian code does not have a very good calculation method for these types of structures. So, as I mentioned, you may have to refer to some European publications. So, I had mentioned the DIN 10, I think, what was it? 1055, part 6. So, you can go to that and you can refer. It's easily available on the internet. I have mentioned this DIN 1055, part 6. You can have a look at it. Okay, so I hope this discussion was meaningful and you were able to understand. Venkatesh is asking, are we designing for maximum force to resist the earthquake? Yeah, by taking R equal to 1.5, we are effectively saying that our system does not have the capacity to dissipate the earthquake forces through inelastic uh, inelastic behaviors. So yes, basically we are doing almost at the elastic levels of design. Okay, so good. And now we go to our third. Now we go to our third segment where we share experiences, and we generally try to meet uh, structural engineers every episode, and we learn from their experiences. Okay, So this time the structural engineer that we have called is going to be you. So because we thought that this is the year ending, and let's make this year ending interesting, so that's why we don't have any engineer as such, but all of you are the structural engineers in today's episode of Meet the Engineer. So what we have thought that anyone, if you want to join uh, the studio with us, they can just click on the link that I have shared in the comment section. You can just join, and by clicking on the link, and we would like to hear from you. So if anyone wants to join us live in the studio, they are welcome to do so by clicking the link that I have shared. I hope the link is visible in the comment section. So we thought that this is the year end, the second last day of the this calendar year. So let us make this episode interesting. So if you are properly dressed, and if you're uh, you are in a proper lighted, well lit environment, you can just join us uh, in the studio by clicking on this link. Yes, anyone who wants to join can do so. In the meantime, I will take questions that were remaining. So Deepak ji is saying installation process is interesting. Yes, installation process is interesting because you do a top-down installation. So you first install the roof, and then you lift it, and from bottom you place the next layer of rings, and so on. Yes. So what we are going to discuss from our structural engineer who is going to join, we'll just understand that what were their learnings in the year 2022, and as 2023 comes, what are their expectations from the new year, and what things they are going to target in the coming year. Right. So what are your targets for the new year? So for me, it would be mainly, mainly continuing with what we do with our projects that we do in our consultancy, plus the courses that we run uh, through the AuxEn. Of course, that will be the target. Plus, the new things that I would like to learn this year would be cold rolled section designs, cold form designs, and I would also be interested in learning about the bridges. So that is one thing I personally would like to learn for this new year. So anyone wants to comment what what would be what is the thing that they want to learn? Yes. No one? Okay. No one wants to join us live. So it was a slight risk that we had taken. We thought that someone of you might join us over the live link. Right. Mr. Anshul is saying he wants to learn the light gauge structural framing systems and connection designs. Very interesting. Yes, so I have shared this link. Last call, or then we will have to move to something else. Okay, so I think no one wants to join us live in the studio. So I think it is much better calling uh, pre-planning and calling you rather than giving a surprise. Okay. So I think just a minute. Yeah. So I think then we will then end today's episode. If no one wants to join us live, okay then. So that's all then we have for this episode. So what we were able to learn, we were able to learn uh, two things. We saw how to apply wind loads in ETABs, and then we had an interesting discussion on use of cold rolled sections for agri storage silos. So that's all we have for this episode, and that is all we have for this year. And now we will see you. Oh, we have someone who has entered, so this will be interesting. So let us hear
Hello,
from
sir.
you. Yes, Mr. Ashish, how are you?
Sir, very fine. I'm following from a long time to you, and I've once I've contacted you to offline courses, and you said that it
Yes,
would not be possible right now, so we will do it online. At
yes.
present, I'm working as a senior structural engineer from a PV consultant, PV vendor, Altis Industries Private Limited. You have
Yeah,
also heard about it.
yeah. So I must tell
So
the audience that Altis Industries is a good industrial PV manufacturing company in Indore. So
yes, sir.
yes, I
So
remember.
I joined them 1.5 year ago, and I have done some good projects there, and uh, before that I have worked with skeleton structural consultant Mr. Jayesh Jain sir. So it was
Yes.
also very wonderful experience after my MTech from SGS ITS,
Okay.
and right now I want to more learn about the offshore structures and LSFG, as you were saying that it is one of the portion of structural engineering which is not so well versed even in codes and in books also. So I also want to learn about the cold form sections structures, and I've in Altis Industries, I've done various projects. I have done a footover bridge in Odisha. It was Adani's project, and we have done some industrial buildings also, not like purely industrial structures. It would be around like warehouse plus mezzanines, and then some equipments load which we have to take dynamic factors also into
Okay.
considerations. So those were the projects we have used. I've heard about your course, which is coming about idea statica, and I am really glad that I would join whenever you will on air that course, because I have used idea statica in our office also for some complex connections, but not thoroughly we know about it. So I would love to learn from you about idea statica. So
Yes.
this was my overall experience, and in 2023, I would push myself to learn some more goods in structural engineering. So I love this fields, and I really love to do it by manually, and by using my pencils and papers instead using any softwares before knowing about the basics. That's why I asked that question, that when we use the portal and portal methods for lateral loads in books, so we generally got two left columns which are on
Correct.
left side of CG. So it may be because of the software that calculated
Actually,
the
it also
structure as a
depends.
whole.
No, no, it also depends on the stiffnesses. When you will change that,
Yes, sir. Yes, sir.
you will notice that the axial load distribution also will change. Of course, the outermost columns will have tension compression couple. In the internal
Yes, sir.
columns, it tends to change with respect to the stiffnesses.
Yes,
Yes, so
sir.
that's
Or
so.
in that method, we have an assumption that hinge will form before that. That's why it's a
Yeah,
very basic thing. So it
correct.
was overall experience.
So thank you for
That's great.
joining the link first of all, because I was thinking whether or not anyone will join. So
No,
we thought
sir.
that instead of calling someone, And pre-announcing, let us have this
Hmm.
interesting round of discussion where
No, sir,
anyone
it
who
was.
wants to join us live can do so.
Yes, sir. It was great
So
opportunity for me to connect with you.
thank you and all the best wishes. I think you are in a good company because you people are doing some really good projects with good engineering, I must say.
Yes.
So your company has a good reputation in this parts of India, Altis. Yeah.
Okay,
So
sir. Thank you, sir.
and thank you that you attend our episodes and thank you.
Sir, I have a question for you. So that when that course will get start?
That we will do tomorrow, not today.
Okay, okay, sir.
Yes. Okay.
Okay, sir. Thank you, sir.
Thank you so much. Thank you. Anyone else who wants to join? This is interesting fun. You can just join live and have good discussion. So last round, last call I should say before we wrap up. Yes, I'm just putting the link once again. Mr. Anshul is asking which software do you use for LG SF design? None. I don't know any software. I don't have any software for LGSF design other than STAD. So I only know how to use STAD. I mean, of course, I know how to use different softwares also, but I'm not using any specific software for LGSF. Okay, then. So I think we will wrap up today's episode. So that's all we have in this year of 2022. So until next year, it is a goodbye from our side. So thank you for taking out time and joining us on a Friday. We did this today because of course tomorrow is 31st, so we thought that let us uh, keep it on 30th, that is Friday this time. So thank you and bye bye. Until next year, it is a goodbye from our side. So be happy, be healthy, and be in good spirits. We will see you in January second week this time. Okay, bye bye.